Expanding brackets. Now I'm going to use two different illustrations to try and get you to understand this. Very important, you're going to use this all the way up to your 12 and beyond, so please make sure you understand the concept. Let's say mum and dad's going to the Eka, and they bring back 3 show bags. In your show bag, there's an apple, 2 bananas, and 30 cherries. Well, it's very healthy. Off you go. But you're 3 siblings, and because mum and dad's fair, they bought 3 of these bags. So they had 3 of these. Right. What your children then do is you come together and you put the 3 bags right next to each other. And you decide, you know what? We're going to put this all together. So you're going to take the 3 bags and chuck out all of this fruit onto the table and then put them together. So what you'll have then in the end is, because each one of you have an apple, you'll have 3 apples, you'll have 6 bananas, and you'll have 90 cherries. Okay, so what we can see then is that 3 of these bags, if I get rid of the bags, if I expand the bags and put them everything inside together, there will be 3 apples, 6 bananas, and 90 cherries. So this is exactly the same as that. Now, you don't want to do this whole exercise every time. That will be, in maths, quite problematic. So what we have is we have the distributive law. The distributive law says this. That doesn't say it. It looks like this. It says that if I have any value in front of a bracket with how many ever terms inside, if I expand the bracket, this A needs to be distribute to each one of the terms on the inside, which means that there's going to be A times B is AB, and A plus C is plus AC. This is called the distributive law. Distributive, coming from the English word to distribute, which will come from another word which I don't know where it is from. So this is the distributive law, and it's called distributive because you distribute, you hand out, you pass on this A to every term on the inside. If there's 5 terms, then this A needs to be multiplied with 5. Imagine there was another 4 pineapples and 6 pears, and you had 3 bags. It means there will be 3 times of everything that's inside that little bag. And if this was a negative, exactly the same thing. It doesn't change at all. If I have a negative here, it tells you A, B minus C equals, and that A will be multiplied into each one of those, and it becomes A times B is AB, A times negative C is negative AC. Right, so that's the distributive law. I could just tell you where it comes from. This is the rule and learn it, but I would like you to understand it. Another way that they prove this quite often, and it might come up in the exercises, and who knows, even in an exam, is when we look at the area. So another popular way to show that expanding of brackets is why we do this. We say, okay, I have a rectangle, but this rectangle is broken up into 2. We're going to say that this is B. We're going to say this is A. And we're going to say that this is, that's painful. I think we're going to wipe out that. I'll fix it so it looks the same as the top. So what I'm going to say is I'm going to say the width of this is A. So that's the width. And the first one is B. This distance is B. From there to there is B. And then this distance, the third distance, is C. So this is the distance from there to there. Okay, so if I look at the total area of this thing, so the total area will be length times width. Okay, what's the length? The length is B plus C. The length is B plus C. Okay, so that's the length multiplied with A, which is the front. A equals B plus C. We don't know what B is, we don't know what C is. Now, forget about the total thing. If we only look at this bit, what is the area of this bit? That bit is pretty straightforward, A times B, and A times B equals AB. We also have this area, and that area is A times C, which is AC. Which means that the total area, which turned out to be surface area, is AB plus AC. Okay, so that total area also equals AB plus AC. So what do we see? We see that AB plus C equals AB plus AC. Okay, so that's the way of proving it. The area there is the same as the area of the total on the outside. Very important, you're going to have exercises on that. Please understand. If you don't, ask a teacher close to you or watch this video again in slow motion.